Hello friends, today we will learn the calibration of creatinine. So creatinine you can see in front of us. This is from the UFT biotechnology, and make sure it should be of high purity. And this is the waste product from the digestion of protein in your food and normal breakdown of the muscle tissue. And also it should be removed from the blood through kidneys, and too much amount can be a sign of the kidney problem, or you can say impaired kidney. And the normal levels of the creatinine in the in the human blood for adult should be 0.74 to 1.35 milligrams per deciliter, or in terms of micromoles it should be 65.4 to 119.4 micromoles per liter, and the low levels are 0.5 to 0.8. And the suitable methods for the detection of the creatinine is by HPLC, high pressure liquid chromatography, and the solubility is at 20 degrees C is 90 milligrams per ml, okay, or it can be 90 grams, okay. In terms of milligram per ml only. You can convert that in grams per liter or milligrams per liter. And creatinine is highly polar, and it's insoluble in acetone or chloroform. Now let's learn how to dissolve in the deionized water. I've taken around 150 milligram. Now I will dissolve that in the deionized water. I will dissolve this for a couple of hours. Better is to leave it for overnight. And I will also cover this with the aluminum foil so that it does not degrade with the light or any other kind of photosynthesis or any other kind of light activity. So guys, now the creatinine is fully dissolved. Okay. So now using the equation of the serial dilution, where C1V1 is equal to C2V2, and here C1 is my stock concentration, V1 is the amount that will be taken out from the main stock to prepare our next stock. So C2 is my next stock. Okay, so we are preparing 50 ppm from the stock solution, which is having 150 ppm, and V2 is my total volume of our next stock. So I have taken here, to be precise, I have taken in 30 ml. So this is the calculation for 50 ppm. Suppose we want to make for 100, okay, so suppose in 100 ppm we are making 30 ml. So this is, so we have to take out 20 ml from 150 and add rest 10 ml will be the distilled water. So now let's start preparing our next serial dilution. So we'll go till 1, 8, and then 5 ppms, 1, 5, 8, 10, 20, 40, 80 and 100. So see is simultaneously we will do the calculation for all the next subsequent concentrations. So this was how much amount we will take for preparing our next concentration. Now I'm going to transfer all the samples to my HPLC vials. So you can see here, this is 1, 5, 8, 10, 20, 40, 80 and 100. And already I have switched on my software, which is called Chromeleon, okay. And after that I have connected all. So you can see this is connected all, and this is my HPLC interface, okay. This is the pump module, this is my sample tray, auto sampler, which you can put samples here, and this is my temperature compartment, and this is my UV compartment. So they all have to turn green. And then the next step that we will do after the transferring the samples is that we have to create the sequence. So sequence using Wizard or sequence using LIMS workflow. So we prefer sequence using Wizard, then we will create a program file, then method file. Okay, so let's start now transferring the standards to the vial, and then I will show you the software part. So guys, after creating the sequence, what we have to do is, so we went from here, okay, so this is my sequence Wizard, and then make sure when you click here this has to be connected, okay, and then go to the next. And then when you choose here for the unknown sample, so you have to choose either use template. So there are, when you click here it is use templates, no unknowns, okay. Suppose we are choosing no unknowns, and then we need to type whatever you are typing here. Suppose you are entering creatinine calibration, and then how many vials you want to choose, suppose 0, and then you will apply, okay. And then if suppose you are choosing 1 here, okay, or again if you are choosing 0, and then go to the next, and then if you go back, so usually you have to keep here for samples, then go next, and then suppose you are choosing creatinine standards and how many vials you want to keep. So I will keep 10 or 8. Suppose we are keeping 8, and then apply. You can see there are 8 vials, and then go next, and then you have to specify where you want to save your program. Suppose you are choosing this one, for example I am choosing this method. This method is already created, so I'll say open, and then quantification method, for example I am choosing this one, open, and then where you want your report, preferred report, the path, suppose I'm choosing default, and then what are the preferred channels I want to use, so column, temperature, oven, so I'm choosing suppose this one, and then next, and then sequence name, test samples, and what is my directory. Okay, suppose where you can choose your directory, specify directory, so say cancel, and then finish. Okay, so suppose I don't want, so I'll say no, then cancel. Okay, now this is my project which is going on. Okay, so after all these, then so the first step was you have to create sequence, then program file, method file, which is already created. Suppose I want to show you program file, so we have to go next, and then here you have to specify the temperature on which you want to work. Suppose you can see here, this is already set to 35, and then lower limit, upper limit, equilibration time. Okay, and then I press next, and then for these one, which column I want to, and then use pressure from. Okay, then next, and then I need to mention here gradient type is isocratic, how much amount of I want. Suppose I don't want, so I'll say this one and this one, and then lower limit and upper limit of the pressure, and then start at 1, and this also, and then next, and then here draw speed, delay, and these things. Okay, draw delay, dispense speed, dispense delay, and sample height, what is my height of the sample, inject and wash both, and then also here wash volume, wash speed, loop factor, and then inject more normal, and then also bypass also. Suppose you want to run and do the bypass, so you can go, then next, and then you want, what is the time you want, 0 to 30 minutes, next, and then auto, and then next, and next, and then you can choose whatever you want to see here exactly. Okay, this is my oven, and then next, and this peak width, data collection, response time, and then you can see apply also if you want, and then you can say apply also, then next, and then you have to enter the title describing your program. Already I have created, and review also you can review, so I'll say cancel. Then the next step for the is now you have to see your method. So method, if this is already saved, it will appear here. Okay, so this was all about how to run or create a sequence using the HPLC device that we have. Okay, and now I would show you. Okay, so for seeing, you have to click here, and then you can see these are my peaks which are coming up for the creatinine. And you can also see them here. Okay, so these are your peaks which are coming up here, you can see here. Guys, now for seeing the peak, so you can see there are a lot of peaks. So these are not our desired peaks. Okay, and so we have two peaks which are broader and which are sharper. So here this is our desired peak. So usually the creatinine retention time, which is 2.4, around 2.4. Okay, so this is our desired peak, and here if you click here on the integration calibration, you can see this is our relative standard deviation, and this is coefficient of determination. And then in the peak analysis we have here, this is our height, okay, of this peak, and then this is my type, and this is my resolution, and this is asymmetric, and the plates. And then if you click here SST and summary, so summary gives you, I mean we have finished around 8 samples, so we are on the 9th. Okay, sorry, these are the first 8 is standard and the 2 are unknowns. Okay, so if you see here, retention time is around 2.4 in all the cases, and the minimum area, if you see here, if we are starting from 1, so this was 1 5, okay, and then we have 8, 10, 20, 40, 80 and 100. So for the 1 ppm, so this height is 0.5771, and this is the 0.78, 0.36, 37. So and this one, actually here if you see here, so we have turned on the 4 UVs. Basically you can use 1 UV, I mean data points, or 2 or 3. Okay, so in this part of the video we'll be focusing more on the curve, on the height and the area. In the second part of the video we'll be focusing on the calibration part. You can see here it is injecting samples simultaneously. Now it is on the, I think, on the last sample. So we have started our sequence from RA1, A2, A3, and then we are going to RB1, B2. Okay, and now this is our audit trial. It's giving you all the methods. And then if you click here on the Q&T editor, so if you see, this is our peak, and then this is showing you the points of the calibration window, and this one is basically pertaining to the first UV, second simultaneous. This is our desired points, okay. And you can name your retention time, you can name your peak, window, standard, and then area, and calibration type is linear, okay, and peak type is auto. Then if you want to see your this one, so if you see again your peak is coming around 2.373. so go into calibration, peak analysis, summary, and then if you go here, so if you see here, if I click here integration, okay, or if I click on the Q&T editor, so this is my calibration window. Simultaneously, if I want to see my unknown, which is the last sample, so if you see here, okay, or if you want to see on the full size, so this is not our peak, so you can even delete here, delete peak, delete, then delete. You can even delete these peaks, okay. And this is your desired peak, which is 19, so your retention time is around 2.44, okay. And these are not your peaks, okay, and these might be some contamination or noises, okay. So let's say yes, and then for example, if I want to see this 7th one, so this is again 2.3, close, and then if you want to see again the 5th one, so this is your peak. So this is all about the usage of HPLC in determination of creatinine, and I hope you understood how to inject and how to create a method, how to create a sequence file, and how to save the method, okay. In our second part, we will learn in detail about the calibration part, okay, calculation of the unknown sample concentration. Don't forget to like and subscribe. So friends, this system is now in dormant stage. So first of all, we have to switch on the system, okay. There is a back switch, and also make sure the power buttons are connected for the main system and also for the software PC system, okay. So now you can see the system is on. Now we have to switch on the software part. So here you can see the main software is our Creatinine, okay. And basically yesterday we saw that the samples were running, okay. So one thing I forgot to tell you is that about the mobile phase, okay. So for the mobile phase, what we have to do is, these are our solvent bottles, okay. So this is my methanol, okay, and this one is my acetone methanol to water, and this one is water 5% methanol, and this one is my mini cube water, which is called ultra pure water. And here also basically to clean the syringes we put the water. So usually the water that we use has to be very pure and has to be filtered using the 0.2 micron cellulose membrane filters, okay. So this point I forgot to tell you.